Hello everyone, welcome back to this channel. So let's do some questions from probability distributions. Okay, first question. You are analyzing human heights in a population which tend to cluster around mean with a symmetric spread. Which distribution best fits the data? See, let's say you are calculating human heights. Okay, now it tends to cluster around mean. See, this is the mean. So maximum values are lying here only and with the symmetric spread. It is not skewed, right? So it will look like this. You can easily say this is a normal distribution, right? Because normal distribution naturally cluster around the mean. Most of the values are lying here and very few values lying in this side, and it is symmetric, so it is not skewed. So this is a normal distribution, right? It looks like bell shaped curve. Once you know that your data is normally distributions, you have pretty much idea about your data set, right? That's why we need to learn the distributions, right? Second question, if you are modeling income distribution where a small percentage of people earn the majority of wealth, so there is a disparity. So from this word you can guess which is the answer. See how it looks. Small percentage of people, let's say people. This side probability of wealth. Small percentage of people gets maximum probability of getting wealth. See, less percentage of people have less wealth, right? So you can see it will look like this. This will be reduced. As the number of people increases, their wealth decreases. And for less people, the wealth is like the highest. So there is a disparity. It is known as Pareto distribution. This is very famous. Okay. Minimum people are holding the maximum of the wealth. The third question. A machine generates random number between 0 and 1. It may be 0.05, 0.06, any number, and each number equally likely. No disparity. Any number can happen. So the outcome is uniform. Anything can happen. Okay, so the distribution is uniform distribution. And it is of mainly two types. One is for discrete, another one is for continuous. Right? And for discrete, you calculate probability. For continuous, you calculate probability density. I hope you know this thing. If you don't know, you have to study. This is uniform distribution. If I roll the die, it may be 1, 2, 3, 4, 5, 6. So happening of anything is equal to 1 by 6. Right? This is discrete uniform distribution. Each number is equally likely. Next one, the data on stock prices. Fine. When you take the logarithm of the values, it appears normally distribution. This is simply log normal. See, when our data is skewed like this, or let's say like this, left skewed or right skewed, then what do? We try to make them look like normal. Then only our algorithm will work the best. So this is done by using logarithm of every values. Okay, this is one procedure. There are many procedures, but one of them is to take the logarithm of this one, right? So that is what they have asked. When you take the logarithm of the values, they appear normally distributed. When you take log, they appear like normal. Before that, they may have any types of skewed form data. Okay, so this distribution is called log normal distribution because it will not exactly become normal, but almost normal, better than your skewed, right? That is why log normal. Next one. Which distribution is appropriate to model the number of accidents occurring at a traffic intersection a day? Per unit time. When you do these types of calculation, that may be from 7 to 8, how many accidents have happened. From 9 to 11, or maybe on Sunday, how many accidents. Or maybe on Monday, how many accidents. When you are just considering the periods, the time period, then you have to go for Poisson distribution. Okay. Next one. You are modeling the lifetime of an electronic device, assuming the probability of failure is constant over time. The probability of failure is constant. So, this is something fixed. You cannot change. And you are modeling the lifetime of an electronic device. See, this one is best weighted for exponential distribution. Because when the probability of failure is constant over time, you have to consider the exponential distribution. Okay. Now the next question. If you roll a fair die, each outcome has an equal chance. This one we have already done. If each outcome has an equal chance, then this is discrete. Why discrete? Because here 1, 2, 3, 4, 5, 6, they are separate number. But when you have to consider some numbers like 0.05, 0.0008, then that will be continuous uniform distribution. Okay. Now the last question for the day. A bus arrives at a stop at any time between 8 am and 8:30 am. And if you arrive at the stop at a random time between that interval. This one also we have just discussed. If you are calculating anything based on time, based on some fixed frequency, then the best suited one is Poisson distribution. Okay, so done for the day. Bye, happy learning.